Всем привет. Мы с Пашей
Hi there.
команду,
Pavel and I
занимающуюся
are from the
автоматизацией
team
поиска и устранения
that
уязвимостей
specializes
Tinkoff.
in
Делаем наши
detecting and
продукты
fixing the
безопаснее.
vulnerabilities. In the Tinkoff
И
team,
сегодня
we
мы
make our
поговорим
products safer.
о том,
And
а
today
все
we'll
ли
speak
зависимости
about whether
мы
all of
знаем.
the dependencies
И
are familiar to
этим
us,
вопросом мы
whether we
задались
know them.
более года назад, когда
We
планировали
asked this question to ourselves more than a
Tinkoff
year
Summer
ago when
2023.
Tinkoff
И наша несколько команд
event
занималась исследованием этого
2023
вопроса,
was planned,
разрабатывали
and
инструменты.
we
И
were
об одном из
developing
таких
the tools
исследованиях
for
мы
that,
сегодня и расскажем.
and this research will be covered
В
here.
целом, это
Overall,
отчасти задача
it is
композиционного
somehow
анализа или
the
SCA,
software
детектор
composition
знаком,
analysis,
и
SCA.
это процесс выделения
It's a
компонентов,
process of
зависимостей
singling
с
out
целью дальнейшего их
components and
анализа, ну и в
dependencies
частности,
for its
например, выявления известных уязвимостей.
further analysis to find out the
В
vulnerabilities
зависимости
there.
от точности и полноты, которую
Depending on the
хотите достичь,
precision and
и
fullness
какой стек
that you
применить,
may want to
могут
reach, and
использоваться
depending
разные
on the stack
подходы.
you might
Ну,
want
в
to cover,
частности, самое
different
популярное,
types of
то,
approach
что
should
можно
be used.
обсуждать, это
The
не
most
какая-то
popular thing
классификация
here,
сканеров,
well,
это
it's not just a
скорее
classification
то,
of
что
scanners,
можно использовать. И зачастую
it's more
это
like what
происходит.
we
Ну,
can
самое
use here.
очевидное — это манифесты
Well,
и различные
the
метаданные.
most obvious things are
Например,
manifests
в
and
Java
different
это может
data.
быть POM
In
XML,
Java, for
это могут
instance,
быть
that's
такие конфиги из
XML, that's
сборщиков типа
the
Poetry,
configs of
Gradle,
poetry,
Maven.
Gradle, Maven.
Собственно, эту информацию используют
This
в первую
information is
очередь такие
used
инструменты,
first
как
and
Trivy
foremost
и
by
Sift
such
для
tools
построения
that
столов.
Privy and
Кто-то
Sift.
использует дополнительно
Some use
различные строковые константы,
additional
сигнатуры, контрольные суммы файлов.
string-based
Ну,
constant,
в
the
частности, есть
checksums of
CVE
files.
tool, ну и
Intel
другие
CV Bean
разработчики
tool
тоже
also
используют
exists for that purpose. CVE,
различные строковые
uh,
константы.
they
Есть более
operate with
изощренные методы, такие
thread
как
constants
анализ
and
кода, анализ
hash
потока
sums.
управления,
Also, there may
чтобы
be
не
the
только
analysis of the
выявить
code,
зависимости, но и оценить достижимость
which may
этого
want to
кода, и тем
analyze the
самым
dependencies
сказать,
and
а вот уязвимость, которая есть, эта
identify the
зависимость
vulnerability
вообще
which is
эксплуатируемая
there, whether
в
it's been
случае или нет.
exploited, whether the code
Если
is
идти дальше, еще более
achievable or
продвинутым,
not.
это
If
уже
we move
разновидности
on,
динамического анализа,
we specialize
когда
in
мы
different
можем
dynamic
смотреть не только
analysis
тот код,
where we
который у нас
check not
виден
only the
фактически
code
и
that is
критически в файловой
visible through
поставке, но и то, что у
selection
нас
or the
происходит в рантайме.
finished artifact, but
То есть
also
это
the
такой
things that we
характерный
have in the
для
runtime,
программ,
which
которые
is very
используют динамическую
relevant
обработку.
to the
Также
dynamic
полезно, когда
linking
мы работаем с
programs,
некоторыми
and
видами
it's very useful when
виртуализации.
we use different types
Соответственно,
of
эта
virtualization.
штука достаточно
So
дорогая,
this analysis is a very
и так много
expensive
решений используют.
thing, I mean, dynamic analysis,
Собственно,
and
в
not too many
начале
people use
исследования
it.
мы поставили перед
In the end
собой
of the
три
research, we
основных
set a task of
цели. Первое, мы
having
хотели
three
получить
major goals. First of all,
возможность
we
выявлять
really
элементы в
wanted to
коде
identify the
без каких-либо
components
метаданных
in the code
и
without
чтобы они могли быть
metadata.
устойчивы
And
к
we really
смене
wanted to be
параметров сборки,
resistant
окружения, целевой
to
платформы,
the
архитектуры
change of the
и
parameters of
компилятора.
the
Что
compiler and the
немаловажно,
architecture, etc.
когда мы предъявляли требования к решению,
So when
заключалось в
we
том, что ведь
had the
в
requests
целом
for that
происходит
solution,
десятки
we
тысяч
knew that
обновлений
dozens of
пакетов
thousands of
в основных
updates of the
репозиториях в
packages
сутки.
do
И
occur
нам крайне
in the
важно с точки зрения
repositories
выявления,
per day. And
выявления
it's very
уязвимостей иметь
important as we
возможность
reveal the
обновлять информацию о
vulnerability,
новых
we update
возможных
this information
зависимостях.
about new possible dependencies.
Поскольку мы с вами собрались на AI-треке, у вас мог появиться
We
вопрос,
are
при чем же
in
здесь
AI track,
машинное
so
обучение?
how come we talk
Давайте
about
непосредственно
machine
перейдем к
learning
теме.
and AI without topic? Well, let's analyze.
Мы остановились на том, что
We stopped
это единственный
at the
вариант.
semantics. Semantics is the only
Параметр,
option
который
here, is the
не
only parameter
изменяется
which does not
в условиях
change
изменения остальных условий.
as we see other
Параметр
conditions change.
компилятора, платформа
We
архитектуры
change the platform architecture, the compiler,
остается
the
неизменным.
semantics of the
Даже большинство
code
видов
remains unchanged.
простой обфускации не изменяют
And even the
семантику
simple
кода.
obfuscation does
Поэтому
not change
мы
the
решили
semantics of the
сосредоточиться
code.
на таком
So we
признаке,
decided to
как
focus
непосредственно
at
код.
this
И
feature as the
второе,
code
посмотреть, а что вообще сейчас есть с точки зрения
and find out what do we have from the tools to analyze the
в данном
code
случае у нас выбор
and
пал
its
на
semantics.
использование NLP методов, которые
And we started to
успешно зарекомендовали
use the NLP
несколько
methods.
языков.
To analyze natural languages, we decided to use them and started to using NLP, natural language processing methods, for the code similarity analysis. Let's just take a look in terms of the similarity of the code. We single out 7 of such things that we find. First of all, it's threat intelligence. Here we can use the classification attributes. We can do it with the use of the code. Google has such things. We keep these patterns even after the compilation, so we may want to use it for attribution. Then we simplify the reverse engineering. We search for more well-known authentication mechanisms. We search the code for certain parameters. With this detection, it's obviously clear. It's the search for the vulnerabilities, intellectual property, dependencies of the licenses that we wouldn't want to use, the search for dependencies, the search for patterns of the code with vulnerabilities, patch diffing of the non-documented things, and the updates of the software. It's a very interesting task, but we stopped at the composition analysis task instead. I just want to point out that we already had this experience of using machine learning to come up with the algorithm of the code similarity, but previously we took a relatively well-known heuristics which were implemented in BenDiff and Diaphora tools, and they use different graph attributes, control graphs, hashing, the search for common constants, different string intervals. So we understood that it's a working tool, but we wanted more. So we thought, what can we find out to resolve our task? The composition analysis of the benchmarks was not found, but instead we found quite a number of solutions which could identify the semantics. That was exactly what we needed. They used neural networks, LSTMs, transformers, and convolutional graph networks. And now let's take a look at the research that we used in our work, ASM2Vec. It's word2vec from the world of the assembler. Those of you who don't know about word2vec, it's the neural network which can be trained to predict the words by context or context by words. So after training, this neural network is involved into embedding the vector representation of the word in the dictionary, and semantic vectors, similar words are related, and semantically similar words, close words, are shown in different contexts. So ASM2Vec offers I can't switch the slides, but anyway, they come up with the idea of predicting not the words, but the entire instruction. Code plus the operand. They take the mean average and do the prediction on that. And they use the window of the size 1. They just take a look at the neighboring instructions. So what can we say? It's a very interesting approach that they have here. They really have very similar codes, very close in the metric space, but word2vec is a very old model. There are better tools, so we have better options. Valhawk, for example, with the transformer used in the base, is the game changer, definitely, in the NLP world. The self-attention. So the idea here is not just to take into account the context of the words as tokens, but also take into account their connection in the sentence. So we come up with a more higher quality embedding, which was really a game changer in the NLP environment. So Valhawk was to compare the snippets of the binary code about finding similarities, and also for different compilers and for different levels of optimization. How do they do that? As for features, they delete all of the information from the code that may change from assembly to assembly, the names, the addresses. For instance, they give the basis blocks to the transformer, and the embedded information is put through the graph convolutional networks for similarities. Search, they take the strings and they build embeddings at strings, and they take a look at the imported functions. To be resistant to the parameters of the assembly, they have this entry test adapter. For different solutions, the distribution of bytes in files is different. So you may want to predict the assembly. They put through the bytes and take this as the shift of the other features. So overall, it's a very interesting approach. But what we see here is that we may want to find the similar binary snippets, which is quite heavy with lots of models. Seems like that practically it will be very difficult to do. So overall, it's just one part of the question why we've not taken any of these models as our solutions. In Valhawk, you just need to mark the data set, and the data set is quite heavy. But another thing is that we do not identify the similar code. Instead of just identifying the similar code, we just need to localize the files as well. What if this library is very small and just takes 10% of the files? And we also resolved that task. We came up with that solution, and now we will speak about our approach. We call it ACML. There are three blocks. Vectorizer comes up with the vectors. With the trains, we put some of the vectors to the vector storage, and at inference, the incoming binary are given to prediction. So there's some machination going on, and we come up with the S-bomb. So as far as the vectorizer is concerned, we come up with the vectors. Well, I should start that we come up with these vectors not for the entire file, but for some single elements of it. We may want to come up with the vectors for function. We may want to come up with the components. We may want to find this for clusters and methods. If it's Java, there are options, but the main thing is just we need to break the file into a number of components. To do that, we just need to disassemble the file. We disassembled the file, and we also took that feature from Woolhalf. We took the features And instead of that, we also take the codes by counterflow graphs. Why do we not simply just give the code there? We take the function. In actual fact, the transformer works with the continuity of vectors. After conditional dump, they may not be just formally the next string. So you may want to have the heuristic approach to that. You may want to come up with this scenario. And we concatenate that and we give it to transformer. Then we'll send this graph information. This control flow graph is needed there. And we limit this by the number of cycles. At the starting phases, we've played that. And here's the embedding picture where we reduced the size of the UMaps, and that's where we show some of the clusters. If we take a look at that, seems like that all these classes and these classes, the model didn't know anything about them, but they turned out to be there through this magic. Now we have some of the vectors in the base. Now we have the file. So what do we do with the file? We have the red files, and we somehow need to match it with the blue ones. So we may want to find out. So it's going to be a very interesting task. It's a very heuristic approach. If this library contains in the analyzed file, then there is a number of elements for which we have created. The vector is in the base. If we have the obfuscated file, the assembly that we don't have as a basis, we think that the obfuscated vectors will not be far away from the actual vectors, and we'll find them in the near vicinity. So let's do it. With all of the vectors that we have received in the analyzed file, we'll find them in the base and make the prediction. For example, the red vectors are here. We found the 3 ones in the vicinity, and we need this vicinity just to extract all of the vectors and exclude those that are not imported. So what are we going to do with the blue ones? With the blue ones, we have the library, so with a high level of probability.
Что за уверенность, это еще, да, надо проверить. Поэтому сначала некоторые резюме надо дать.
So let's make a quick summary out of what I've said. What do we do again? On the train, we come up with the vectors, we pull it in the base, and the infinity, we extract those vectors from the file, and
в общем, делаем prediction. Но вот, теперь надо поговорить про реализацию. С идеей мы
we just need to speak about implementation.
Наверное, стоит начать с базы.
I think with the implementation we start with the vector base, what we would like to get from the vector base, to quickly search for vectors.
Здесь мы решили взять open-source базу.
We decided to take the open source Milvus database. They have an article where they explain what they made to avoid cache misses with a bunch of indexes, algorithms that can provide a very fast search.
Еще нам нужно дезассемблировать
we also need to disassemble.
Тоже open source проект.
We take the open source
Для всех
project
архитектур и форматов
for all of the architecture.
замечательный open source
It
проект,
works.
но
It's an excellent open source
не обошлось без багов.
project.
Мы в
We
ходе
could not
нашей работы
avoid
нашли
the bugs
критический баг
in
в
there.
построении control flow графа, исправили его.
We found the critical bug in the control flow graph.
И нужно еще поговорить про данные, то есть это тоже часть реализации.
And here's yet another part of the implementation.
В качестве данных, на которых мы будем тестироваться и проводить
As of the data that we use for testing, we took the
архитектуру сборки, и мы по пакетам
jar
можем найти
files
позитивные зависимости,
because we can identify the
активные
dependencies.
транзитивные
We
зависимости.
may want to identify target
Мы
dependencies.
несколько проводили экспериментов, несколько подходов. Мы сначала
We
начали
conducted a few experiments. We started with a few ones,
потом уже
with
поставили
a
себе
small
цель
data
100
set,
тысяч пакетов
and
раскатиться.
then we
100 тысяч
decided
пакетов,
to roll it for
получилось много фичей.
100,000
Еще раз
packets.
фичей мы, возвращаясь назад,
A lot of features were generated, and we
которые
use
построены на
control
ассемблерных,
flow graphs, which were based upon
на
base
базовых
blocks,
блоках. И, в общем,
bytecode-based blocks.
оказалось, что очень долго это все
All right,
получается, и мы
so it just takes quite a long time. 80 kernels, 430 gigabytes of JSONs. We did it once, and then
тоже итеративно улучшались.
did it,
То есть мы сначала решили просто сложить все
and
вектора в
we
базу,
decided
свыше
to put all of the
неимоверное
vectors
количество
in the
векторов на
base.
71 гигабайт. Мы
There
решили,
were
что, блин,
71 gigabytes worth of vectors, so we decided to
база,
eradicate that,
искать
combat that,
по
to
векторной базе
very
нужно,
quickly
чтобы
provide the
процессор
search through vector arrays. We just wanted to put the data set in there. We didn't have enough RAM for that, so we just removed and eradicated the duplicates from the vector base. And it seems like that we had lots of vector duplicates. We wanted to come up with the embeddings for Java classes. As an element, we took Java classes, but instead we pushed to the methods. They were less than 2.
Собственно, на этот момент мы
So in actual fact, right there, we accumulated a critical number of fuck-ups. So we would like to share these fuck-ups with you. If you really want to borrow some ideas from us, reproduce our results and polish them and improve them, please do not fall into the same trap as we did. Number one, first of all, we couldn't really understand why would we have random quality selection problems. We decided to have this random analysis, and the packets that we received, the wrong evaluation says that our solution says that the packets are identical, but in actual fact we see that they are different versions. It turned out that those were the packets, that their version was different in the packet manager, but the code was absolutely the same. So it could be just because of the change of the license, change of the developer, and if the packet was moved from one repository to another, or just change of the name. So we just need to take this separately. The second problem were assembler-related mistakes that affected the quality, and we'd come up with full logs, and we pulled out the problem, and it could not be disassembled with jar tables. We fixed that. But it seemed that control flow graphs were also made in the wrong way. We fixed that bug as well. And so we think it's not just a problem of resin, it's or rising as you pronounce it, but the quality of disassemblers. So far we have not seen any single disassembler without bugs. These bugs are very difficult to hunt for. And as for vectors and duplicates, Java has so many boilerplates. So it seems like that one vector may repeat with 100 and 1,000 times. And we come up with the request, find me 7 neighboring ones, and you get 7 of them instead of 100 nearby. It slows down our work, and we
вектор в какой библиотеке встречается. Это важная информация, как мы выясним потом.
Have very important information about how long it takes to measure each vector in the library. Yes, and in the very beginning, we wanted to have a very sustainable, compiler-resistant solution, and we couldn't just verify it with Java. We have a hypothesis, a bit of hypothesis. We met with our speakers. They came up with lots of JDKs. They said that they generate different code. But in actual fact, all of the JDKs we tried and tested, more than 15 of them. They use open JDK, and the bytecode turns out to be very identical to hash. And so we couldn't really check the Java resistance. We took the different path, POG art for changing of the code, and we use different obfuscation methods. And one final thing in our implementation, we wanted to speak about models and parameters. We had a couple of experiments. We tested that at a small data set, and we took Roberta. The wolf hack was Roberta. We decided not to think much about that, but then there was a big data set, so we thought that Roberta is actually slowing down, so we better take a smaller model with a potential production possibility. And with the CPU inference, we took it simply, and we tried all mini-LM, and the quality did not degrade much, so we stopped at that. We were limited time-wise, but as far as parameters go, we had experiments. Initially, we had a very small data set, and we also took obfuscation into account. So we took 7 nearby vectors, and when we rolled it out for a bigger data set, so we didn't have enough time to check the obfuscation, and we conducted the experiment, knowing that the files are not obfuscated. So let's just move to experiments and their results. But now a little bit of an intro. First of all, a chart. Where do we take this data set from? We made a synthetic generation of a data set with 1,000 packets, from 4 to 15 libraries, which were selected out of it from the data set. With this search in the base, we filtered the vectors by the frequency, as frequently as they pop up. Very often there are libraries that contain one single class, 3 methods, and these are gators, resetters, and if you do not filter them, there'll be so many faults, so many fails. So we cut some of the vectors that we see in lots of libraries, and we conducted experiments using them. And we wanted to check and verify some applied part. We wanted to detect CVE. So we came up with yet another data set with CVE packets with CVE and Maven repository. And as far as metrics go, that's what we want to find out through experiments, and whether we'll have very big tolerance within one packet. So the more false positives we generate, the smaller the metrics, and the share of the correct dependencies revealed. The more false negatives, the smaller the metrics. And there are different versions of the same packet. They may be different in some ways, but the byte code is the same. It's not an error if we've given a few versions of the same package, and if they are all the same version, some of them is, of course, the authentic one, the genuine one. What's the result? If we take the vectors, that we see here in no more than 40 libraries. We have this 0.64 average element precision, but we have a very good recall. So we have approximately 12% of the precise predictions.
Зато предсказание, где false negative равно 0.
Where false negative equals 0, but false positive is a lot, like 50%, as far as I can see. Let's experiment and see what happens if we move this and check how well we filter the vectors. If we minimize occurrence, we'll lose quite a lot. On the right-hand side, you'll see how it reflects the predictions. So we just change the occurrence as well, 3 libraries. So the precision, element precision grows higher, but element recall gets lower. That's what was expected. And now, for example, the information about the strings, because previously we spoke about code and vectors, but if we add information about the strings, it seems like it's a win-win situation, because we do not push down on either element precision or element recall, but we are losing the obfuscation possibility, so we pay the price for that. The question is, why not use the strings here? You add the strings and the quality goes up. Maybe it's all about the quality. Okay, let's try and do it. The precision really suffers here. So if we disassemble it manually, at the constants, there are plenty of false-off versions. They do not help us detect the version properly. But the code does help with that. But it's also a feature of Java. In Java, the constant is a very strong feature, because the constant in Java contain constants of methods, but in some other way it may be showing even worse results. And when we take the changed data sets with the different libraries, different versions, with either having the vulnerability or not, we got 0% of CVE false negative, where the model did not see the dependency of CVE. When we had the vulnerability, we always revealed that. In 60% of the cases, there were false positives. When we spoke about having this dependency on the vulnerability, which was not actually there. What's the conclusion and summary? Actually, this approach in our implementation can be used and utilized with not fully automated, but somehow automated analysis. With this number of false positives, you can replicate it manually and you can use it. Like, for example, an unknown binary arrived to you and you do not trust it, and you can disassemble this binary and see what it potentially contains. So potential vulnerabilities can be double-checked with hand manually. So this solution that we had can be developed further on. We have some ideas how to do it. And you can move in 2 key directions. First and foremost, we improve the quality of embeddings. We experimented with trigger floss, triplet loss. We needed to change the triplet loss approach. We need to repeat the experiment with triplet loss, take another transformer which is more suitable for pre-training using the bytecode. But if we do this transformer for every architecture, for every language, we yet have some mapping translation between them, and it will complicate the solution. But we can, of course, toy with the filtering of the vectors by expanding or reducing the search field. That's where you can experiment with different frequency
перспективы у развития
characteristics. And I think the prospects for this approach do exist. Those of you interested, please come up to us later on. We are ready to share this solution with you, ready to share the benchmarks, and would like to remind you that we spent a little bit more than 2 months to do that. So currently, this solution is being developed, and some of it is being transferred into internal products that we use, and we use it in production as well. Tomorrow we will have a report we'll share with you where we will speak about an alternative approach. We could resolve that in a different way without analyzing the code, but using the MML as well. We'll speak about that tomorrow. This method is very demanding to the computing resources, and we could not launch it to analyze millions of artifacts per day. We decided to instead simplify this solution, optimize that, and we'll speak about this tomorrow, as I said. Thank you very much for listening. We're open for your questions.
Давайте начнем с первого вопроса.
So we'll start with question number one. Did you somehow evaluate your solutions? Is there any metric to evaluate your solutions? Can you share your insights with us? Come again?
Можете ли вы поделиться
Can you share the evaluation of the performance of your model?
Ну вот смотрите,
And the measures taken. Exactly.
элементный precision recall.
We showed the element by element precision recall, and you have actually everything. If you have this information, you can do everything. Actually, it's not about classification that was our task.
Хотели посмотреть в пределах одного
Again, we wanted to take a look at one packet and check how many mistakes we'll have there, how many errors. We focus on one single tool, manual tool, and see how much manual work will be added to scale it up.
Было справа, да, вот кружок, можете посмотреть, сколько точных, сколько
You
неточных.
saw at the slide how many precise predictions, how many imprecise predictions were shown there.
Некоторых протухло, так что
Obviously, some of them questions are already out of date, so don't take offense. Can you integrate this solution into a certified fuzzer?
Мы знаем только о одном сертифицированном фазере.
We all know just about one certified fuzzer, Pfizer, as we say,
обсудить
and we are ready to discuss it if you're interested. But in actual fact, it's not quite clear. If you're asking about Pfizer,
не очень понятно
Pfizer,
про то,
we're not,
как планируется использовать гибрид фазинга и
we do not understand how we
наверное, как-то можно.
combine SIP approach and fuzzing approach.
вопрос, пока мы не забыли все. Следующий.
Don't forget to select the best question, by the way, as you read other ones. You guys, are you planning on sharing these research with the community so that you develop this whole idea, this approach of the analysis of the software? Yes, of course, we said that we are going to share it. Our contacts were at the slides. We are ready to share it with you privately with the data augmentation and the data set. We'll share it with you. Here is a question for you. The creator of the prompt injection answers keeps finding vulnerabilities in every single presentation, and he asks, or she asks, maybe he's not he, but something else, somebody else. Can a code have a worm embedded to attack the systems of code analysis? It depends on the target of the attack. We do not run the code. We have the tool like Reason, which disassembles it. We can run it if there is such an opportunity, a possibility, but this whole disassembling is done in a separate sandbox, so the impact will be limited. Most likely, we just fail to get the
Давайте
results
следующий вопрос.
of the analysis. And
Какой
yet
вариант
another
создания
question,
эмбеддингов вы использовали?
which
И как
embedding
оценить, в принципе,
model did you
качество
use and
формирования
how
этого
did you
эмбеддинга?
analyze the quality of this
Хороший вопрос,
embedding?
спасибо.
Good
Как мы
question, thank
оценивали
you.
качество, по
The
сути,
way we analyze the
заключается в
quality
наших экспериментах. То есть мы не придумали ничего лучше, кроме как
is about our
максимально проверить
experiments.
качество
We just
эмбеддингов на
checked the quality of the embedding
какой-то вот такой околоприкладной задаче, хоть и
at the
синтетически.
applied
целом,
synthetic task.
Я даже не знаю.
I don't really know how to put it. Maybe you help me.
Совещание.
So they are in a conference. Well, anyway, we took the models from Hugging Face and we took them and we got acceptable quality with element precision and element recall. And we checked this, we saw it with our own eyes, with the expert evaluation, and we unsupervised method, which was later used, the quality after adding that method was improved significantly. So we recommend you use native code
Друзья, мы не
to
заканчиваем
analyze
задавать
that.
вопросы, но у нас, для вас, всех вас, есть некоторые линии, которые мы сейчас
We have an announcement to make, and then we'll go back to Q&A. At 1 o'clock, 1 p.m., we have a test where you can get some merch, limited edition, so please go. You will have a QR code here. Please come.
На конкретный квиз тоже будет высвечиваться периодически.
So from time to time you will have this QR code. Next question, please.
Видимо, шарит за
It's a question, it's not me.
Расскажите,
Kyle
как
looks
выходе из
at,
дома с помощью LLM. Если да, то какая?
as a crowfish. So we don't use LLM for spam. We have a well-determined matching algorithm, which we described. We have a set of components, versions, and then an adapter, which goes to DX, to well-determined set. Let me specify. You didn't get about prediction block. We use transformer to get vectors. We have indexed vectors in the database, and by comparing vectors that we got from the file and from the database, we make a prediction by a well-determined algorithm. LLM is not used here. Next question, please. Did you analyze a binary code without disassembly? If yes, did you teach Roberta?
Задайте его завтра.
It's a good question. Please ask it tomorrow, because we'll have a separate presentation yesterday about exactly that thing. But let me give you some answer. Yes, we tried it. Yes, the advantage is that you don't have to waste time for disassembling. It's a difficult process. The clear binary can provide you good information for analysis. Yes, what you wouldn't be able to do easily without disassembly is control-fold graph and split by element, methods, classes, and so on. Thank you. And the last question, please.
Утверждает, что существуют разные методы обфускации, некоторые из них...
There are different methods. Some of them doesn't change the code semantic, others change that semantic. What about your approach? We noticed that we have to go to virtualization when the code section is changed and the logic is changed. We can create two applications with one exact code with different data. When AST3 changes, but the algorithm stays the same, so the method operates in a quite stable way. Thank you very much. Thank you for your questions and answers. What is the best question? What do you think about the binary code?
В общем, да, вот вопрос...
The binary code, yes. Without disassembling, yes. Where is the author? Please go right there when the speakers can give you your prize, well-deserved prize. At 1 p.m. we have a quiz. Tomorrow we shall have more. So thank you once again, dear speakers. And now let's pass over to the next presentation. Warm welcome.